Hello everyone, my name is Ran. Today I am going to give a talk about LatentDR, improving model generalization through sample-aware latent degradation and restoration. This is a work done by me and my collaborators at Georgia Tech. As we know, it is challenging for deep learning models to generalize well to samples from domains that are not seen during the training process. Thus, achieving robust out-of-domain or OOD generalization is one of the most fundamental challenges in the field. For example, considering one of the most classic domain generalization datasets PACS, the models trained on art, photo, and sketch domains typically do not perform well in the cartoon domain. There are so many different methods that are proposed to address this issue. While in this work, we focus on and investigate the following problem: can we design latent augmentation techniques to build out-of-distribution robustness? Specifically, can we further increase the diversity of the source data by simply manipulating the existing features in the feature space? One thing that we observed is that, when training a simple supervised model, the source data that belongs to the same classification label would, naturally, form different clusters in the feature space based on their similarity. This clustering within the same classification label is based on extra information in the data that is not relevant to the provided classification guidance, for example, which domain it belongs to. We hypothesize that such clustering would hurt OOD generalization because it focuses on irrelevant information that is not semantically important that should be ignored. Based on this intuition, and inspired by the recent progress in the diffusion models, we ask if it is possible to create latent space augmentations through the degradation and restoration process to get rid of such irrelevant information. Specifically, consider each data point as a query example in the latent space indicated by the red star. Every one of each such query would contain two types of information: the information that is relevant to the classification process and also the information that is not necessary to the classification process. We consider an augmentation process that first adds noise to blur such fine-scale details in the representation, and then recovers or restores the most important semantic information. We hope that generated latents help with out-of-distribution robustness because they are less affected by the details that are irrelevant to the classification process. Based on such intuitions, we propose a novel latent augmentation technique, LatentDR. It is a flexible plug-and-play module that is designed as such, considering an encoder F that transforms many samples from different domains to the representation space, where the representation is later classified by a classifier G. The learned representation would naturally contain information about the domains, which are information that are not relevant to the classification task and would hurt OOD generalization. To correct that, we first use a degradation transformer that treats each latent representation within a batch as a discrete token and use self-attention to degrade the latents equally. We achieve this by mapping the degraded latents to generated soft labels, which is an average of labels within the batch, and then train the same classifier on them. This process would effectively blur the representations by creating challenging examples. After this, we employ a restoration transformer to restore the latents. We use the cross-attention technique, where the original samples are treated as keys and values, and the blurred representations are treated as queries, to recover the remaining information within the blurred representation that is useful for classification. Through this process, the recovered latents are encouraged to preserve the class information, and the unnecessary information or details within, like the domain information, would still be blurred and corrupted. Thus, during inference, when given an example that contains the same class information but unseen domain information, because the training data is augmented such that there are more diverse examples that contain unexpected domains, the model should be more robust to unseen and new domains, and thus perform the classification performance better. To understand if the proposed method is effective, we examined the performance of the LatentDR on the domain bed benchmark with 5 different datasets. One interesting fact in such datasets is that ERM, which is simply training a cross-entropy loss based on the empirical risk minimization scheme, presents a robust baseline in this domain. Our approach, when coupled with ERM, can effectively boost the performance, giving state-of-the-art performance using a ResNet 50 backbone. To understand how LatentDR improves performance, we examined and found that the encoders, trained with LatentDR, can give better uniformity in alignment of features, providing representations that are more diverse or spread in terms of uniformity and closer for data with the same classification label in terms of alignment. Through the nearest neighbor retrieval on the right-hand side, we found that the augmented samples can effectively connect information across domains, building more variability to the latent space. We further validated the versatility of LatentDR on 2 other tasks, and we found that LatentDR can improve the performance in medical imaging classification tasks by augmenting images with strong domain shifts, and can also improve the performance in long-tail recognition tasks by adjusting the data balance in the latent space. To conclude, in this work, we propose LatentDR, a novel approach for latent space augmentation that builds connections across samples by degrading and restoring samples from the latent distribution. We validated that LatentDR is effective across various evaluation metrics, helping the encoder to build a better latent space in terms of uniformity and alignment metrics. We also examined the effect of LatentDR in a few different settings, including the medical imaging classification and long-tail recognition tasks, showing that LatentDR could be a versatile plug-and-play component. Thank you for your time and attention. Our code is available at the below link.